All right, everybody, welcome to the Eureka Math series. This is still Module 2, and this is Lesson 2. Once again, this is Maestro Maravilla. All right, so without further ado, let's get into that lesson. So lesson number 2 is interpreting division of a whole number by a fraction. Visual models. All right, so first thing you guys got to know over here is in the previous lesson, we were dividing fractions. So for example, we were dividing fractions by like a whole number, right? Over here in this lesson, we are going to be dividing whole numbers by fractions. All right, so just keep that in mind. All right, so the other thing to keep in mind is that when you have a division expression, say for example you have 6 divided by 1/2, right? You can then take the reciprocal, right? That's the multiplication part. And then you can say 6 times. Then we're going to flip or do the reciprocal in the second fraction, 2/1. And that will give you the same answer. All right. So that's kind of like equivalent fractions there. All right. So just keep that in mind. All right. So again, they're the same because, saying 6 divided by 1/2, think about it, right? If you're breaking 6 into halves, that's going to give you 12, right? Because you're dividing 6 wholes into halves. 6 wholes divided into halves. So it's 2 per whole. And so if you have 6 wholes, then that's going to give you 12. And here, when you do have the multiplication, then you can multiply 6 times 2. That'll give you 12. Remember, there's a 1 under here, so you multiply 1 times 1. That'll give you 1. That still will give you 12. Okay. And so if we want to make a model, we look at the second fraction. So we look at the 1/2. And we do the model. So we do 2. Okay, so we do 1, 2. And so we're going to need to shade 1 out of the 2. So 1 out of the 2. And that is going to have a value of 6, right? This is 6. So if that one is 6, then the other one is also 6, and you have a total of 12. And that's my answer there and there. Okay, so that's how this works. So let's go ahead and continue. Let's go to the original. Let's go to the next page. Okay, one thing to keep in mind here, you guys, again, here we're going to have to fill out this chart. And when we fill out this chart, one thing to keep in mind is that in the previous lesson, I introduced you to keep, change, flip. And flip here is the reciprocal. Okay, so again, every division expression has a corresponding multiplication expression, and this is where we implement the reciprocal. All right, so look at question number 1 here. Question number 1 says, how many 1/2 miles are in 12 miles? So what are we going to do? Okay, so what we'll do is we are going to get think about what they're asking us, right? They're saying how many 1/2 of miles are there in 12 miles? So they're actually telling us if you got 12 miles, you're going to break that into pieces of 1/2. Then how many 1/2 miles do you have, right? Now, if you remember, this 12 is a whole number. So we're going to put a 1 under, all right? So then to do the equivalent multiplication, we do keep, change, flip. So we keep the first fraction, 12/1, change from division to multiplication, and then flip the second fraction right there. Notice that this 1 is now part of the denominator, and the 2 is now my numerator. All right, so that was the flip or the reciprocal to make an equivalent multiplication expression. So then I'll have 12. I like to keep the 1 under, divided by 1/2 is the same as 12, keep, right? Multiplied, change, and then flip. There we are. All done. Okay, so let's continue. Next question. How many quarters are in 5 hours? So what they're saying is you got to take this 5 hours and you got to break it apart and figure out how many quarters you have. All right. So then the equivalent multiplication expression, the reciprocal, that will kind of be like the flip part, right? Remember, that's the flip part right here. All right. So first of all, we're going to keep the first fraction. I like to put the 5 under. 5. Keep the 1 under. Now change from division to multiplication. So from division to multiplication and the flip. Now the 4 is in my numerator and the 1 is my denominator. Now we combine them together. So then we would get 5. I like to keep the 1 under. Divided by 1/4 is equal to, once again, this is my division expression. To find my multiplication expression, I got to do keep, change, flip. So keep my first fraction, I got 5. Change from division to multiplication. And then flip my second fraction. So now the 4 is my numerator and my 1 is my denominator. All right. This is one way to solve fractions. All right, you guys. Let's move on to the next one. Let's go to number 3. Number 3, once again, how many 1/3 cups are in 9 cups? So they're saying that you got to get this 9 cups and you got to break them into pieces of 1/3, right? So how do we do that? Again, this is my division expression. I got to turn it into a multiplication expression. So the way I do this is I keep, right? Remember, I'm just adding the 1 under the 9 to just make it a fraction. Change from division to multiplication and then flip my second fraction. And then that's it. Put them together. This is my multiplication, my division expression. And then I'm going to then do keep, change, flip to come up with the multiplication to an equivalent multiplication expression. So I keep my 9. I change from division to multiplication, and then I do the reciprocal or flip the second fraction to come up with a equivalent multiplication expression. All right, so that was number 3. Let's go to number 4. So number 4, how many 1/8 of pizzas are there in 4 pizzas? So once again, I got 4 pizzas, so that's 4 holes, 4 pizzas, and I have to break them into smaller pieces of 1/8 each. That's what I have to do, and then figure out how many were there in total, right? How many pieces were there? So then that's my division expression. Now I got to do a multiplication expression. Remember, I keep the 4. Again, I like to just use the 100 just because when you actually have to solve, you do have to multiply that 1. So 4 is still a 4, right? 4 over 1 is still a 4. So I kept that one and then changed from division to multiplication and then flip. Now the 8 is my numerator and the 1 is my denominator. So once again, if I combine them together, I got my first division expression. So 4 divided by 1/8 is equal to 4. Keep and then change from division to multiplication and then flip. Now the 8 is my numerator and the 1 is my denominator. All right, so that's how we're going to do this. Okay, so let's move on to the next one. Let's go to number 5. So number 5, okay. So how many 1/5 are there in 7 holes? So again, they're saying that we have 7 holes, right? So 7 of them. And those 7, we are going to break them into smaller pieces of 1/5, right? So if we break them into smaller pieces of 1/5, this is my division expression. Now I have to come up with the equivalent multiplication expression. So what I'll do is I'll keep the 7. I like to put the 1 under. And then I change from division to multiplication. So change that symbol. And I'm going to flip the second fraction or do the reciprocal. And so 5 over 1. Okay, so now once again, 7 divided by 1/5. It's the same as 7. So keep, multiply, change, and flip by 5 over 1. All right, fair enough, simple enough. Let's move on. Let's move on to the examples. So example number 1. Molly has 9 cups of flour. If this is 3/4, of the number she needs to make bread, then how many cups does she need, right? So once again, we kind of look at if we construct a model, right? If we're gonna construct a model, we're gonna say that we're three. We're gonna make the diagram. We need 4 little squares in this tape diagram. So 1, 2, 3, and then 4. But we're only shading 3 out of the 4. 2, 3, and then those 3 have a value of 9. Okay, so that's the value of those 3. Now, if I know that those little 3 shaded squares have a value of 9, then I gotta break them and figure out what the value of each one is, right? If there's 3 and they have a value of 9, well, then all I gotta do is then divide the 9 by 3, and that gives me 3. So that tells you that each one of these three little squares have a value of 3. So then if those 3 squares have a value of 3 each, so the one that's not shaded is also worth 3, and therefore my answer here is going to be 12. Okay. If I do this using algebra, so then what I'll do is, again, I shaded the 3/4. I did that right there. So this is my 3/4 right there. Went a little too far. Nope. Here we are, a little too far. Okay. So this is my 3/4 right there. But they also have a value of 9. So 3 out of the 4, and they have a value. Okay, so 3 out of the 4, 3 out of the 4, but they have a value of 9. Okay. And then again, I figure out that because there's 3, if I divide by 3, then each one has a value of 3 for a total of 12. Okay. If I do this using algebra, so what I can do is I can say, okay, I got 9 cups, and I gotta break them into pieces of 3/4. Okay, so then I'm gonna do my keep, change, flip method. So once again, I'm gonna add a 1 under the 9, just so I can keep it as a proper fraction. So then we're gonna say we're gonna keep the 9 over 1, or the 9. Now we're gonna change from division to multiplication. We're gonna flip the second fraction. So 9, 4, and then 3 at the bottom. Okay. At this point, then I say to myself, can I make this a little easier? The answer is yes, because I can look at the 1 and the 4, and at the 9 and the 3. Now, the 1 and the 4 are already prime numbers, so there's nothing I can do about them. But the 9 and the 3, those I can simplify them because they can both be divided by 3. So I scratch the 3, make it a 1, cross out the 9, make it a 3. So then I just multiply. 3 times 4, that would give me 12. And then 1 times 1, that would give me 1. And look at that, this gives me 12. So once again, this is my same answer that I had right there. All right, so it's I ended up with the same answer, 12. So it works. Okay. So once again, label the shaded region to show 9 is equal to 3/4. I did, right? Because this 3 out of the 4 have a value of 9. So we did that. And then finally analyze the model to determine the quotient. So we solved the problem. The answer is 12. All right, guys. So let's go over to the exercises now. Exercises 1 through 5. Okay, so let's look at number 1. Number 1 says a construction company setting up signs on 2 miles of road. If the company places a sign every 1/4 of a mile, 1/4 of a mile, then how many signs will we have? Well, I mean, if we do a model, we're gonna draw the road. So we'll do this. All right, this is my road. I'm gonna break it in half, but then I'm gonna break it in fourths. Now we only need 1 out of the 4, right? So we need 1 out of the 4. So once again, this 1 out of the 4. This is 1/4, right? But that also has a value of 2 miles, right? That has a value of 2. Now, if that has a value of 2, then this is 2, this is 2, this is 2, and you have a total of 8 signs, right? So that one was simple enough. If we want to do this algebraically, we can do keep, change, flip. All right. So we'll do keep, change, flip, and remember that the flip is your reciprocal. All right. So our so what the question is asking us is saying we have a 2 mile road, and these 2 mile roads we're gonna place signs every 1/4 of a mile. So we're gonna divide it. Okay, so we're gonna divide it by 1/4. Okay, and that's gonna tell us how many signs this road is gonna have if you place them at a 1/4 mile marker each. So let's do keep. So we're gonna keep the 2. I like to keep the 1 under. Okay, so look, I started with a 2, so I'm keeping it for keep. Okay, change. Now look, I have a division symbol, and I'm changing it from division to multiplication. Finally, the last fraction, and I'm gonna flip it, or I'm gonna do the reciprocal, the 1/4. Now I have a 4 and a 1 under. So this one here was flipped. It was changed. See that? Okay, it was flipped. So now that I have them like that, I can just simply multiply across. So I can say 2 times 1, 2 times 4, that'll give me 8. And then 1 times 1, that'll give me 1. And so my answer is 8 signs. So this row is going to have a total of 8 signs if you place 1 at a 1/4 marker each. All right, so let's move on to number 2. George bought 4 submarine sandwiches for birthday party. If each person will eat 2/3 of a sandwich, then how many people can George feed? I'm looking at the amount of people that George can be able to feed. So how are we going to do this? We can do a tape diagram. Okay, so we can break it into 3. There we are. So 3 different parts. And remember, we're going to only shade 2 out of the 3. So shade 1, shade 2. Okay, this right here, this one is going to be 2 out of 3. So this has a value of 2/3. But these 2/3 also are worth 4 submarines. So 4 submarines. All right, now if you know that these 2 little squares have a value of 2, then you already know that each one of those has a value of 2, 2, and then 2. So then if you add them all up together, then 2 plus 2 is 4 plus 2 is 6. So your answer is 6 friends. 6 friends will so 6 friends will have a will be fed. Right, is my answer here. Okay, so if we do this using algebra, we got 4 sandwiches broken into 2/3 of a sandwich, and that's how many each one's gonna get. So how many friends can he feed? So again, we're gonna do this using the keep, change, flip method. So we keep the 4. I like to keep the 1 under. Change from division to multiplication, and then the second fraction we're gonna flip it or do the reciprocal. Okay. Now I ask myself right here, look at the 1 and the 3. Can I simplify them even further? No, they're already at the lowest they can be. But if you look at the 2 and the 4, then those I can simplify. I can cross out the 2, make it a 1, because 2 divided by 2 is 1. Cross out the 2, make it a 2, because 4 divided by 2 is 2. So now I multiply 2 times 3, that'll give me 6. 1 times 1 is 1. And so the answer is still 6. So they match. There we are. All right. So let's look at the next one, number 3, Miranda. Miranda buys 6 pounds of nuts. She puts 3/4 of a pound in each bag. Then how many bags can she make? All right, well, once again, let's do a tape diagram. 3 out of 4. 1, 2, 3, 4. So I got 4. I'm going to shade in 1, shade in 2, shade in 3. Okay, so I'm shading in 3 out of the 4. That's right there, 3/4. But that also has a value of 6 pounds. This is 6 pounds. So if that 3 out of the 4 has a value of 6 pounds, then I have to divide by 3. So 6 divided by 3, that's 2. So each one of these little boxes is worth 2, 2, 2. So then the last one must also be worth 2. So then if I add them all together, 2 plus 2 is 4, plus 2 is 6, plus 2 is 8 bags. And that's my answer right there. My answer is 8 bags. Once again, I can do my keep, change, flip, or reciprocal method. Okay, so keep. First of all, my original division expression is going to be 6 divided by 3/4, right? Because I got those 6 pounds of nuts, and I can fit 3/4 of a pound in each bag. And so by doing that division, it's going to tell me how many bags I can use in total. So now I have to do an equivalent multiplication. So I'm going to keep the 6, put in the 1 under, change from division to multiplication, and then flip the second fraction to 4/3. So 4/3. All right. Can I simplify? Yes, I can. The 6 and the 3 can be simplified. The 1 and the 2, not so much. So let's look at the 3 and the 3. I can cross out the 3, make it a 1. Cross out the 6, make it a 2. Why? Because I can divide 3 by 3, that'll give me 1. I can divide 6 by 3, that'll give me 2. So now I multiply 2 times 4, that'll give me 8. 1 times 1, that'll give me 1. And so my answer is still 8 bags. And there you go. My answers do match. I did tape diagram, or I did the algebraic model by first writing a division expression and then doing its equivalent multiplication expression by the keep, change, flip method. And then I just solved by multiplying those across. All right. So question number 4. Margot freezes 8 cups of strawberries. If this is 2/3 of the total strawberries that she picked, then how many cups of strawberries did Margot pick? Okay, I'm going to look at the second fraction, and I'm going to do my model based off of that. Okay, so I'm going to do 2 out of the 3. So I'm going to do 1, 2, 3. All right, 1, 2, 3. So there we have it. So you have 1, 2. Now keep in mind that I shaded 2, right? Because that is my 2 out of the 3. My 2 out of the 3. But they also have a value of 8 cups. If those 2 shaded parts have a value of 8 cups, and that tells you that each one has a value of 4 cups. This is 4 cups for a total of 8 cups right there. So therefore, I'm missing another 4 cups. And therefore, 4 plus 4 is 8 plus 4 is 12 cups. All right, and that's my answer there. So again, how many cups of strawberries did Margot pick? The answer is 12. I can do this algebraically once again by using my keep, change, flip / reciprocal method. All right. So first I have to have my division expression, and that's going to be 8 cups of strawberries, and I'm going to break them into 2/3. Okay, so again, that's my division. I have to make an equivalent multiplication expression, and I do that by the keep, change, flip method. So keep the first fraction, keep the 8, put the 1 under, change the division symbol to a multiplication, and then flip the second fraction. So the 3 now is the numerator, and my 2 is my denominator. Now, before I multiply across, I can simplify, right? The 8 and the 2, this 8 and this 2 can be simplified. The 1 and the 3, not so much. But the 2 can be crossed out and turned into a 1 because 2 divided by 2 is 1. 8 can be crossed out and turned into a 4 because 8 divided by 2 is 4. So 4 times 3 will give me 12. 1 times 1 will give me 1. So that's 12 cups. So there's my answer. They match. Makes sense. All right. So you can do the model there, the tape diagram, or you can do the algebraic solution here. You can do the division expression followed by its equivalent multiplication expression, and then do the reciprocal. So you can just multiply across and solve. Okay. So let's do number 5. So for number 5 says Regina is chopping up wood. She's chopped up 10 logs so far. If the 10 logs represent 5/8 of all the logs that need to be chopped, how many logs does it need to be chopped? And once again, I'm going to do my model based on the 5/8 and the second fraction there. So what I'm going to do then is I'm going to do 1, 2, 3, 4, 5, 6, 7, and 8. Close my tape diagram there. Now remember, Regina has only chopped out 5/8, so I need to shade 1, shade 2, shade 3, shade 4, shade 5. So I'm only shading 5 out of the 10. But if you look, those 5 out of the 10 represent 10 logs so far. So those 5 out of 8 represent 10 logs so far. So then I got to figure out what the value of each one of those little squares is. I got to figure out what the value is, right? So to do that, then I have to divide 10 by 5 because that's 10 logs, and there's 5 squares that I shaded. So then I got to divide 10 by 5. Okay, so let's do that. If I divide 10 divided by 5, that'll give me 2. So that tells you that each one of these is worth 2, 2, 2, 2, 2. There you go. That's my 10 logs right there. And so therefore, the remaining pieces are also worth 2, 2, 2, for a total of 16 logs. And that's my answer. That's the amount that need to be cut for the day. If I solve this using algebra, so I have my division expression, that's 10 divided by 5/8. So 10 broken into 5/8. I'm going to do my multiplication expression by doing keep, change, flip. So I'm going to keep the 10. Remember, put the 1 under. I'm going to change from division to multiplication. So change. Okay, so once again, keep. Okay, change. And then I'm going to flip my second fraction. Now the 8's at the top and the 5 at the bottom. So I flipped or did my reciprocal. Okay, so there they are. And then I forgot to write the word flip here. So let me write flip. So keep, change, flip. And this goes all the way over here and up. Okay, keep, change, flip. There we are. So now I say to myself, can I simplify this? The answer is yes. I can simplify the 10 and the 5. The 8 and the 1, not so much, because the 1 is already a prime number. So I can cross out the 5, call it a 1, cross out the 10, call it a 2. Why? Because 5 divided by 5 is 1, 10 divided by 5 is 2. So then I multiply across. 2 times 8 is 16, 1 times 1 is 1, and 16 over 1 is just 16 logs. All right, and there's my answer. So next up, you guys, is a problem set. Go ahead and work on those. Good luck. Let me know if you have any questions. You can put them on as a comment. And then I will try to answer those questions as they come up. All right. If you found some value in this, give it a thumbs up, and we'll see you in lesson number 3.